This is lesson 30. It's VHDL example 16. And in this example, we'll make a 4-bit binary to gray code converter using the algorithm we developed in the last lesson. And to do this, we'll introduce VHDL for loops. Remember from the last lesson, this was the algorithm to convert any binary number to the corresponding gray code. You remember you copied the most significant bit, and then for each smaller bit, the GI was just BI plus 1 exclusive OR with BI. This was the circuit that we saw could produce a conversion from a 4-bit binary number to the corresponding gray code number. And this was the algorithm that we wrote in terms of this for loop. Now this suggests that we might be able to use a VHDL for loop to generate this circuit. And this turns out to be the case, and let's take a look at how we can do that. Well, here is the VHDL program to do it. The input B, in this case, is just 3 down to 0, B3, B2, B1, B0. And the output G is also 3 down to 0. And using the algorithm that we developed, we can just write G3 is B3, gets B3. And then we use this for loop. And this is a VHDL for loop. It looks a little funny, but this is the way it works. You say for I in 2 down to 0 loop. This means you start with I equal 2, and you go through the loop. Then this is end loop, 2 words followed by a semicolon. And so then GI is just assigned BI plus 1 exclusive OR with BI. That's the algorithm. So the second time through the loop, I will be equal to 1, and then the last time I is equal to 0, and that's the termination. So it generates this. Now, what's interesting to note is that this is the hardware that gets generated. Remember, this for loop is a VHDL for loop, and remember VHDL is a hardware description language, so we're generating hardware. So this first statement just basically connects this output G3 to B3, and then the first time through this for loop, G2 is just B3 exclusive OR with B2, so this exclusive OR gate is generated. And then the next time through the loop, G1 is B2 exclusive OR with B1, so this exclusive OR gate is generated. And then the last time through the for loop, this last exclusive OR gate is generated. So for loops in VHDL, every time through the loop you generate new copies of the hardware. That is, in this case, a new exclusive OR gate gets generated. Now, of course, we know that in our FPGA there really aren't any exclusive OR gates there, but that doesn't matter. The circuit is equivalent to this, even though it's going to be implemented in our lookup tables in the FPGA. Okay, let's look at the see if this works. If you simulate that, you'll see that in fact if we make the binary input go from 0 to F, then the gray code goes 0, 1, 3, 2, 6, 7, 5, 4, C, D, F, E, A, B, 9, 8, which if you check back you'll see that's exactly the gray code that we had for our 4-bit binary number. And you'll notice that the gray code, only 1 bit changes as you go from one gray code to the next.